So like I said before, every class period we're adding tools to our tool belt. The very first time we learned about power rule, which is like the basic derivative. Then we added trig laws or trig derivatives. And now we're going to do something called the product rule. Product rule is the first time we are going to be able to take the derivative of something that's multiplied together. So the derivative of the product of two differential functions, and we're going to go through both. So we're saying we're taking the derivative of some function that is multiplied by some other function. That derivative is the derivative of the second function, the regular second function times the derivative of the first function plus the regular first function times the derivative of the second function. Now that's a lot of notation, so we're going to start changing the way we write stuff. And I've seen some of us already try to do this and just put primes on regular letters instead of f of x and h of x. Now we're going to be able to do that because that's the notation that we use for the product rule. What we're saying, because there's a lot less letters happening here, if you have two functions multiplied together, the derivative is v u prime u v prime. The way I remember this, product is plus, v's are on the outside. Product is plus, the v's are on the outside. Okay, vu prime plus uv prime means that we're going to have to find the derivative of each part and then combine them into a larger derivative. Are you ready to see your first one? No. That's the spirit. Okay, for g of x, we're going to find the derivative using the product rule. Here's what I notice. I notice that we have our first function, 6x. That is a linear function. And we have our second function, sine of x. That's a trig function. There are two separate functions that are multiplied together. There's no plus or minus between them, so we can't like separate them and do the sum and difference rule. This is the product rule. What we're going to do is we are going to assign 6x to be u, and we're going to assign sine of x to be v. See how I've just separated them into the first part and the second part? We take the derivative of each part separately. U prime is going to represent the derivative of 6x. What is the derivative of 6x?
6.
Great. What is the derivative of sine? Cosine. So now that I have u, v, u prime, and v prime all written down, I just have to put them back in the correct order for the derivative. So we would say g prime of x is going to be equal to v u prime plus u v prime. See how I've just put it together? If you feel better putting everything in parentheses, you totally can. And for right now, I'm going to show it with a bunch of parentheses, but it's not necessary. The ones I wrote the first time are absolutely necessary. Now, of course, there's a nice way to rewrite this, we always try to put the polynomials first and the trig function second, if possible. What I mean by that is, when we clean this up, we would write this as 6 sine of x, so constants in front, or constants and x values in front, times cosine of x. So the derivative of 6x times sine of x is 6 sine of x plus 6x cosine of x. Did we follow? vu prime, uv prime. V is on the outside, product is plus. Can we try another one? Great. We want to take this derivative. I'm going to continue with this color code just because it's helpful, I think. The first term, or the first function is going to be in red, and the second function for me is going to be in blue. We need to assign them as u and v, and then take their derivatives independently. So u will be this first thing, 4x squared, and v will be 7x minus 3. U prime represents the derivative of u. Yes, you get to take that little notation now. It's much easier than writing du over dx every time. This would be 8x, and v prime would be what? 7. Okay, can we put it all together? F prime of x will be v, and since v is a polynomial, I'm going to put it in parentheses. U prime plus u times v prime. Again, if you put everything in parentheses, that's like an easier, safer bet to make sure you're not missing parentheses. This would be fine, but I'm going to go ahead and put this 4x squared in parentheses just to be sure. Oh, this should be blue. Oop. Okay. Now we got to clean this up. To clean this up, since this is all polynomials, what can we do here? Distribute. This is going to be 56x squared minus 24x plus 28x squared. Now I'm allowed to do this, and I didn't do it on the last one because the last one was a linear times a trig function. This is a polynomial times a polynomial, so we have to continue to multiply the polynomial out because then we have a whole like term situation happening here. 56 plus 28 is 84x squared minus 24x. That is the derivative of the function we started with, using the product rule to answer.
And if we leave our answer like that, what would be correct?
If you leave your answer like which one?
Like that.
Like this?
It doesn't have prime, no?
Well, it does, because look, this is prime.
So we do that.
And this says, once you've told me prime, you can just put equals all the way down the paper. But if you don't tell me prime, I don't know what you're doing.
Okay.
So like what if there's like multiple functions?
If you're going to confuse yourself by not putting equals, put the name of the function. If there are multiple functions floating around.
No, as in like what if instead of like 2 there's like 3 or like 4?
Oh, like product of 3?
Yeah.
That's going to be a different situation. This is just for the product of 2 differentiable functions. Can we try another? And by we, I mean y'all. I'll get you started. The way I'm going to help you get started is by helping you write down u's and v's only. You got it from here. Here's the nice thing. I know your spidey senses are probably saying, that x is in the denominator, we're going to have to do something with it. Cool. Do it whenever you write down u's and v's. My u function is going to be 3x minus 1. My v function, I would just go ahead and write down x to the negative 2. That's the usable version to take the derivative. Now there will be some cleanup for this one, but I want to see what your brain thinks to do for cleanup. So I'm going to let you guys try this one. Let's see what you get when you take the derivative using the product rule. Okay, if we keep going, now that we had a chance to think, u prime would be what? 3. And v prime would be? Okay, and we're going to leave it like that for now. We will clean it up before we're done, but because it's easily usable in this format, we start there. To take the derivative of this function, it would be v x to the negative 2, u prime, which is 3, plus u times v prime. Okay, to clean this up, what would we need to do? Distribute. So these would be multiplied together. It's not like truly like a distribution moment, but like kind of feels like it. This would be 3x to the negative 2. I will finish cleaning it up in a little bit. And then we have this distribution. So a monomial times a binomial. How do I multiply those? Big numbers times big numbers are always the same. 3 times negative 2 is negative 6. How do you multiply bases with exponents? We add them, so we have positive 1 plus negative 3, which is negative 2. And then repeat that process. Negative 1 times negative 2x cubed is positive 2, not cubed, x to the negative 3. Are there any like terms here? Yeah, x to the negative 2's, right? So we have 3 and we subtract 6. That means we have negative 3x to the negative 2 plus 2x to the negative 3. Last step here for cleaning it up, this would be negative 3 over x squared plus 2 over x cubed. And that's the derivative. Notice again, it does say dy dx, so every time I say equals after that, I'm talking about the derivative itself.
So you have to put them both into fractions?
Yes. Because the fraction, like there was no negative exponents when we started. And truly, there really shouldn't be negative exponents. That's just like a nice cleanup step always. But if they happen to leave it as a negative when they give you the problem, then fair game to leave it as a negative when you finish. Did we get close or at least on the right track? The calculus part we probably got because this was the only moment of calculus. All of this is all algebra. Cleaning it up. Last example problem on the front. We have f of x equal to sine of x cosine x. If I were to write this down as u's and v's, what would u be? Sine of x. I know it's up there. I can't reach it, so. What's v? Cosine of x. Okay. We can take the derivative of both of those. What is u prime? Cosine of x. What is v prime? Negative sine of x. Can I leave you here to put this together with the product rule? All right, you got it. If we just follow the pattern, vu prime, uv prime, we should have cosine x times cosine x plus sine of x times negative sine of x. How did you simplify this? How'd you clean it up? Cosine squared of x. And I know my spidey senses when I saw this were like, is that Pythagorean identity? Is it? Look at your formula charts on the back. Is this the Pythagorean identity that we had when we did trig identities? They're added. So it's very tempting. And if it was a trigonometric identity for Pythagorean, we could totally go ahead and simplify it. This is not, because it's sine of x, sine squared of x plus cosine squared of x that's equal to 1, not minus. So this is done. But definitely fair game to bring those back if they happen to be a Pythagorean identity.
If I switch the order, and will it mess up like my answer or not?
It will not. No, the order doesn't matter in this example because we're using addition, which can happen in any order, and multiplication, which can happen in any order. When we learn the quotient rule next time, there'll be a subtraction sign, then the order matters. But for this one, because everything's positive and multiplied, the order doesn't matter, as long as they're opposites, like u and v prime, and u and v and u prime. That's a good question. Do we feel okay about the product rule? For the most part? Great, let's go to the back. Here's some more ways the product rule can become part of a question. It says the following table lists the values of the functions f and g and the derivatives for values of x. Let k of x equal to f of x times g of x. Well, what did they just give us? Essentially what they've done is instead of giving us the functions f and g, they've given us the evaluated form, meaning f of negative 1 is negative 2. G of negative 1 is negative 3. So those are the points at that particular part of this graph. These are the slopes at those particular parts. So they've done the plugging in for you. There's not even an equation in this problem for you to use. We're just going to use the values in the table. The first problem here says to find k prime of negative 1. Well, k prime, if you look, is f of x times g of x. So it is the product of f times g. which means we can use the product rule to figure out what this is equal to. To make this easier on us, I'm going to go ahead and write the letters U and V underneath these two things so we know what we're looking for. K prime of negative 1 means that we are looking for V, which is G, at negative 1, times U prime, which is F prime of negative 1, plus U times V prime. So instead of using V's, I'm using F's and G's in function notation, but this is the same thing. VU prime, UV prime. It's just going to be all at a particular number, and that number is negative 1. So if we read the table, what is G of negative 1? G of negative 1 is negative 3. Great. What is F of negative 1? Negative 2. Oh, sorry, F prime. Boop. What is F prime of negative 1? 6. So sorry. And what is F of negative 1 for real this time? This one should be negative 2. And G prime of negative 1, negative 3. Do we see where I'm getting these numbers from? Straight up from the table on the row that says negative 1. Well, now it's all numbers. No, I'm not writing an equation anymore. I'm just getting a value for K prime of negative 1, which is using the product rule. Negative 3 times 6 is negative 18. Negative 2 times negative 3 is positive 6. So we should get negative 12. Bless you. Can I have you try one kind of like this? We're just reading values out of the table, making sure you put them in the product rule order. So for this next one, you are finding K prime of 1 instead of K prime of negative 1. But I'll leave it showing so you can see both. Go ahead and give that one a shot. So similarly to part A, when we're finding K prime of 1, we use the product rule, which is second equation times first equation derivative plus first equation times second equation derivative. But this time it's all at a particular point. So we just have to read off the table. G of 1 is 3. F prime of 1 is 6. F of 1 is 2, and G prime of 1 is 3. Which means I have 18 plus 5, and we should have gotten that the slope of K at point 1 is 23. Did I?
Yeah.
Totally viable. What did I do?
It's 18 plus 6. You forgot to multiply.
That is so embarrassing. Ooh. Okay, I fixed it. We'll blame it on a Monday. How about that?
And tomorrow and Wednesday start.
Yeah, thank you. Give me more excuses. In parts C and D, it's another way to ask questions from a table. This one says, find negative 4 times the derivative of f of x plus g of x. Now, question. Since there is a plus right here, do I have to use the product rule? Product rule is for only when it's a product. This is a sum. So no. What I'm going to do is I'm going to pretend, and this is the sum and difference rule that you just kind of understood. I'm going to take the derivative of both f and g separately because they're not multiplied together, they're added together. So this problem is essentially asking for me to do negative 4 times f prime of 2 plus g prime of 2. Because I'm going to do the derivative of each part separately since it's a sum, not a product. Now, where did the 2 come from? Yeah, it's particularly asking at the value 2. Well, again, those are just numbers from my table. What is f prime of 2? 24. What is g prime of 2? 6. 24 plus 6 is 30. 30 times negative 4, negative 120. So these tables aren't just necessarily going to be for the product rules. Sometimes they're going to be for our sum and difference rules. Now, if that's the case, are we going to be using the product rule in letter D? No. In letter D, again, because it's a sum and difference, we're going to be able to take the derivative essentially of both f and g separately and then evaluate. But I'm going to let you guys practice this one. Did y'all get 21?
Yes.
Hooray. Now this time, just to make a difference between why I didn't multiply by 3 over everything, can someone tell me why I didn't multiply 3 by everything? Yeah, it's only wow, I just forgot the whole word I was looking for. It's only a scalar multiplier to f, not the entire function. So it's only a coefficient of f, not the entire function. All right, we're adding tools to our tool belt. So guess what question's back? Finding the equations of tangent lines. All right, we got to do point slope again. So it's the same exact process. The only difference is when we take the derivative, this is going to end up being a product rule. So the same way we've been doing this, when we find the equation of a line, what do we need to find first?
Slope.
Well, yes, we will need that. I guess it doesn't matter what order we do it in. I was looking for the word point. We're going to find the point, then the slope. Of course, order doesn't really matter, so it doesn't matter how you do this. But we're just going to find f of 1. Why f of 1? Because x is 1. So all I'm going to do is plug in a 1 everywhere there was an x, which would be 1 times 1 minus 2. So 1 times 1 minus 2, which is negative 1. That would be negative 1. So I have a coordinate point, 1 comma negative 1. We feel good about that step. When we go to find the slope, however, I'm finding the derivative. Now this is a product. We have x times 1 minus 2x. So when we go to find the derivative, we need to find u and v. Well, u is going to be x. V is going to be 1 minus 2x. What's u prime? 1. What's v prime? Negative 2. So when we do the derivative is v times u prime plus u times v prime. That's the only piece of calculus. Now we just have to clean it up. 1 times 1 minus 2x is 1 minus 2x. X times negative 2 is negative 2x. So this simplifies to 1 minus 4x. Now that's the slope generator. What do we need out of this function to get the slope at that point? Plug it in. So we're going to do f prime of 1. which is 1 minus 4 times 1, which is 1 minus 4, or negative 3. Once we have a point and a slope, we just write point slope form. It would be y minus y1 equal to m. I'm doing all sorts of the wrong color scheme here. Let me try that again. Y minus y1 equal to m times x minus x1. Yes? So same kind of question as we've had before, just when you take the derivative now, it could possibly be a product rule. Or it could possibly be a table, now that we've seen these. This question says, in the table below, r and t are differentiable functions. Find the equation for the line tangent to q of x at x equal to negative 3 if q of x is made by multiplying r of x times t of x. So we're still trying to write an equation. So when we write an equation, we need a point and a slope. I'll label my steps here so you can see what's happening. Number 1, we find the point. To find a point, we plug a number in. Okay, well if I plug the number negative 3 into q, that means anywhere in the q function there was an x, I now put negative 3. So if I do r of what number? Times t of what number? Those are all x's, so I change them to negative 3's. This is something I can read out of my table. What is r of negative 3? Negative 4. What is t of negative 3? 2. So my coordinate point is going to be the coordinate point negative 3 comma negative 8. So I still just plugged it in, and it's just weird because you plug it into two functions because they combine and multiply to make the third function. After I find a point, I find a slope. But to find the slope of q, that's going to require the product rule. We'll go ahead and do it specifically at negative 3. So what would I write first? Let's see if we got it. Our formula is VU prime UV prime. Remember, the first function is u, the second function is v. So v is t of negative 3. What will be next? R prime of negative 3, because it's VU prime, plus, what next? U, which is R, yes, all of the letters, times what? There we go. That's the product rule with different letters. Lots of letters floating around today. T of negative 3 is what number? 2. R prime of negative 3, negative 2. We're reading this out of the table. R of negative 3, negative 4. And T prime of negative 3, 3. That's negative 4 times negative, or plus negative 12. Is that right? Yes. Equals negative 16, yes? All right, so now we have our point and we have our slope. Now we just fill in equation. Those steps are always the same. It's just that possibly finding our derivative is a little bit different each time. This would be y minus y1 equal to m times x minus x1. And voila. Comments, questions, concerns about the product rule?